Alright, in this video I'm going to do a second example of solving quadratic inequalities algebraically. So whenever we're solving a inequality algebraically, we actually want to first solve it for as if the inequality sign was an equal sign. So I'm actually going to rewrite example 2 as 2x squared plus 3x is less than or equal to positive 2, but instead of this inequality sign, I'm going to actually switch it to an equal sign. Now, by solving this, what it's going to do for me is it's actually going to find me critical values that I can use to solve the top inequality. So to solve this quadratic equation, I can first get everything on one side, so subtract 2 from both sides. I'll get 2x squared plus 3x minus 2 equals 0. And then from here I can factor this into two binomials. So 2x times x, if I multiply those two, they'll give me a 2x squared. And then I want to think about what two numbers multiply to negative 2. But when I FOIL these two binomials, they have to add to a positive 3. So just for a second here, I'm going to write down below what would happen if I did this wrong. So for instance, if I put a 2 in this spot, and let's say I put a 1 over here, and maybe I make the 1 negative and the 2 positive, so that when I multiply those, I get a negative 2. Notice that if I FOIL this, if I take 2x times x, I will indeed get 2x squared. And if I take 2 times a negative 1, I will indeed get negative 2. However, if I take the outer terms multiplied together, well, 2x times a negative 1 is a negative 2x. And then if I take 2x times x in the middle, I'll end up with a positive 2x, and I won't get 3x in the middle. So instead of putting them in this order, what I actually need to do is put the plus 2 on the right and the negative 1 on the left. And now you'll notice when I multiply these two inner ones, that'll give me a negative 1x. And if I multiply the outer two, 2 times 2x is really going to be 4x. And notice if I combine those, I would indeed get the middle term. So now that I have this factored as 2x minus 1 times x plus 2 equals 0, I can actually rewrite this as two separate equations, and then all I have to do is solve those two equations. Well, if I add 1 to this side, I'll get 2x equals 1. Then I just simply have to divide by 2, and I'll get x equals 1/2. And then on this equation, I just subtract 2, and I get x equals negative 2. Now, once again, what I'm solving for here are known as critical values, and we can use critical values to help us find the solutions to the inequality above. So the way we do this is we can actually make a number line, and on the number line we can go ahead and graph our critical values that we found. So for instance, maybe I'll put 0, and then I know I'm at a half, and then I'm also at negative 2. And then I noticed that I had a greater than or equal to sign, so I can actually fill in these points on the critical values because they will be solutions in my final answer. Now, if you notice my number line here, the critical values kind of split it into 3 regions. I kind of have my first region to the left here, my second region is kind of in the middle, and then the third region is off to the right hand side. Now what I kind of want to do is just test some values in each of those regions and see which ones give me a true statement when I plug them into the equation. So for instance, if I test this negative 3, well, if I take 2 times negative 3 squared plus 3 times a negative 3, I should get a value less than or equal to 2. Well, negative 3 squared is 9. 9 times 2 will end up being 18. Well, then if I take 3 times negative 3, well, that's really just negative 9 is less than or equal to 2. And at this point, I can clearly see that if I take 18 minus 9, I'm not going to get something less than or equal to 2, so I'm not getting a true statement. So I know my solutions to the problem are not going to be in region 1. Now, continuing on the same line, I want to test region 2. So if I plug in a 0 into my equation, I can actually kind of do this one in my head. Notice that 0 squared will just be 0. If I multiply that by 2, it's still 0. And then if I take 3 times 0 in the next term, well, that's going to be 0 as well. So this whole left side will end up being 0. And then is 0 less than or equal to 2? Yes, it is. So actually, this second region does indeed work. And then lastly, maybe I'll just test the third region just to make sure that this region should not work. So if I plug in 2 times 1 squared plus 3 times 1 is less than or equal to 2, well, 1 squared is just going to be 1. If I multiply that by 2, I'll get 2. And then if I add 3 times 1, which is really just 3, is that less than or equal to 2? It's clear here that obviously this is not going to be true. So once again, my third region does not work. Now that I know which region does work, I can actually use this information to write my final solution to this inequality. And the way it kind of works is the x values that work, the solutions, are between the values of a half and -2. And then notice that the dots are filled in, and I do have an equal to sign, so I actually still use the same sign. So both of these less than signs should be equal to. So the solutions to the inequality 2x squared plus 3x less than or equal to 2 are going to be all the x values between -2 and a half.